So now we are going to talk about module 4.4. So let us kind of bring certain threads together. So we talked about isolation privileges before and also today for compartmentalization of code and so on, and using user ID as a way of compartmentalizing in terms of access rights and so on. But we saw that Windows also have similar problems as Unix. For example, you can have Windows rootkits which can leverage dynamically loaded kernel modules where it bypasses all the access control. Windows registry has it's a hierarchical global database, and usually it is associated with a security context and that limits the access, but we know that various malware can actually edit the registry and make breach that security context. And many Windows deployments also come with full permission and functionality enabled for history writing and so on. Now last thing about authentication and authorization is a few things about password. So we all have been told many times that your password must be strong, it must contain a special character, it must contain at least one capital or small, and also it should contain numbers and alphabets and so on and so forth. But let us look at some of those rules again. Since this is a security class, you should be familiar with how to form your password, and even then and how passwords are breached. The most common logical access control is through password. Sometimes it is called a logical token. It is a secret combination of letters, numbers, special characters, and we know that we have been told many times that passwords should not be written down, and it must also be of sufficient length and complexity that the attacker cannot easily guess it. There are many password myths, so let us look at some of them. Sometimes they will say that this has special characters, so this is a stronger password than this very long password, but actually small ones are easier to break, so it should not be too short and can be easily broken. That long one is probably safer. The best length of the password is 8 characters is also a problem. It should be at least 15 characters as they say. So that is another problem. Replacing letters with numbers such as JOHN, instead you write a 0 is good, but password cracking programs actually can look for those combinations, so it is not necessarily going to give you any extra security. Passwords cannot include spaces. Now that depends on the system you are using, so some password programs or many password programs actually allow you to use spaces and special characters. Now what kind of attacks happen on password? So one is brute force attack, so you start guessing, but most of the programs today are actually limited, gives you a limited number of tries, and after that it times out or it locks you out, so that usually does not work. Now passwords are stored in the system usually in a hash form, right. So if the attacker can steal the file of hash passwords, then they can break the hashed passwords offline with a number of techniques. So how do you get the hashes? There are many software that you can download, and you can actually come with the cracker, and then you can actually get the hashes. Now there are two kinds of attacks most common for passwords. One is the dictionary attack, there is the rainbow attack. So one is that most people would use English dictionary words, used to, now no longer, with some numbers or something to do this password. So therefore if you use that dictionary words, then it is easy to crack your password. Now rainbow tables are specialized tables, so you basically create a huge data set of hashes from nearly every possible password combination. So you can do this offline for many months you can create this and then even put this in an a world accessible place where people can actually download a rainbow table and then can use rainbow based attacks. Now it works well against Windows password because Microsoft does not use salting techniques for computing hashes. So what is a salting technique? Okay, so just before we get into salting technique, if you are using a dictionary attack, what happens is that for every word in dictionary the corresponding hash is stored somewhere, and then when you actually get the encoded password file somehow, and for example in case of Unix, Linux, it is usually the slash etc slash shadow file. You have only access to that if you are root, but there are ways to get around that. So so shadow file, if you can get access, then you start looking for match against this file, and if you match then you go back and see what has been translated to this after hashing, and then you know the password. But normally today nobody is going to use a simple dictionary word to do this. Therefore people have started generating rainbow tables. So rainbow tables take advantage of the fact that you can do this offline for many months, and there are other people who have been doing this. So you can basically join force and have many rainbow tables of various possible combinations, millions and millions of combinations, and you have to have a fast search strategy, matching strategy against rainbow tables. So how effective is rainbow table can be seen from this table. So if you have a 8-digit password of all letters, brute force will take 1.6 days continuous tries, whereas rainbow tables can do this in 28 minutes. 9-digit with letters and numbers, 378 years, 28 minutes. 10-digit password of letters and numbers with mixed cases, 23,481 years, here 28 minutes, and then 14-digit passwords also, it is really fast with rainbow table. So this is how it is, and as I said that on Windows this is particularly useful because let us say you have a password P and you hash it and you become P hash. So P hash has to be matched against a rainbow table. So let us say it matches, you find P hash here. So when you go back you will find P. However, if you arbitrarily randomly add something P followed by some Q, then what you are storing here will be, instead of P hash it will be P Q hash. Next time you do P, you will be using R as your salt, so it will become PR hash. So by looking up PR hash or PQ hash on rainbow table, you cannot determine that the password is P. So that is what salting is all about. Now Microsoft older versions did not do salting, and therefore you can, once you know a P hash and you match it in the rainbow table, you know that the password is P. So two accounts with the same password, if without salting, will have the exact same hash, and therefore you can speed up the password cracking against the pre-computed rainbow table. So and you can actually test this on older like Windows 7. See, you hash the same password and then you will get the same hash irrespective of which user has done, and not only that, on a different installation of the same operating system for the same password you will get the same hash. So that is pretty dangerous because it does not do any salting. Whereas if you go and look at Linux, so you basically add, let us say you add a user using this command, then you type in the password and then you change the password, and then you do another user and you give the same password. You go into the shadow file and look at the last two entries, those are for those two users. You can check that by looking at the username, and then you see that the hashes are completely different because they have been salted. to summarize, a strong password policy can provide many defenses against password attacks, and this is very important to do it enterprise wise or inter-institute wise, because if somebody's password gets breached, all of us might be in trouble, because somebody is inside your system with malicious intent and they can do various things, and that is why using other techniques such as phishing, emails and so on, when people get into the system, all of us are vulnerable. So, the first password policy is to create and use strong passwords. One of the best defenses against rainbow table is to prevent the attacker from capturing the password hash file, as I said, /etc/shadow file. Fine. So, usually that is protected for reading only by the owner, but it can happen otherwise. And final defense is to use another program to keep track of the passwords. So there are many applications nowadays that help you keep track of your or many different passwords. So, even if you keep very strong password, you do not have to remember them, because you have a master key through which you can go into that file and get the password as and when you need. Setting password restrictions for Windows domain can be done through Windows domain password policy, and usually there are some 6 common policy settings that you can do to create a domain password policy. So, Windows have this notion of domains, and the domain password policies will, for example, expire your password regularly. It will not allow you to do various simple passwords and so on and so forth. These are the various 6 different policy things in Windows, and enforce history, like for example, like many systems do not allow you to reuse the last 3 passwords. The recommended is 24 before he can repeat, but nobody does 24, that is too much. The age of the password maximum normally recommended is 42 days. A minimum password age should be before you can change it, to prevent some arbitrary change in password by somebody. Minimum password length should be at least 15 characters. It should require complexity requirement, like it should have this number, that number, this special character and so on, that should be enabled. And stored password using reversible encryption, that is a no, so that should be disabled. So, that finishes this mostly about access control and modularization or compartmentalization of programs, and how to do isolation of various compartments of the program to limit the damage that might be caused by higher privilege user being exploited. And then the next part will be on browser isolation. So, we will talk about that in the next class.